Hey ideas, it's going to be a little bit of a long video. I'm going to show you some things about the axle peg, about what makes that weird, maybe how to get that in there a little bit easier. We'll see how that works out. Then I'm going to put together the train itself. Um, so let's start to get to it here. Um, let's see, let me pull up, oh, wrong thing. So there you go, that one and that one. So let's go ahead and you see in my OnShape I've got 8 parts currently made. I've made a new part studio. Gone down here, clicked new part studio, and renamed it. Right clicked right there, rename, and I have it CY underscore axle peg. I'm going to start a new sketch on this front plane, and I'm going to draw out the general shape of uh, my axle peg kind of right down the center here. I'm not paying attention to any dimensions at the moment. I'll come back and I'll fix these in a moment. Um, so it looks something like that. Then I've got an arc that connects those two. Two different ways to do that. I could do a center point arc. I have a center point arc, so I'm going to do that one. I'm going to click on this line, click there, and eventually that's going to need to connect up with there. I'm just going to leave it dangling in space right now. I could coincident them. I think that might be an I, yeah. So I is the, if I coincident them, then I got basically the general shape. I'm going to start from my smallest dimension here, uh, just to try and put this thing together. I think that's going to work the best. So I'm going to hit the D for dimension. My smallest dimension is right here, and it is 0.031. It's going to shrink this thing way down. Zoom way in here. The height on the head there is 0.125. Happened. Click. Oh, I see what happened. I need to go to the front view. I should pull that so you can see that. And zoom in more. You see that circle, even though it's spherical radius, now looking, I don't know, like a Pachycephalosaurus. We've been doing dinosaurs at my house. Um, let's do the top portion here. Get the dimension on there. Come on. Is across the top there. It says it's 0.25, but we're only doing half of that, so we can divide that by 2. Moves that out. From here to here, this will start to make things a lot better. That says it's 0.422. So 0.422 divided by 2, because again, we're only drawing half of that. All right, it's starting to look better. Here's where I think I find that it's going to break. If I put in a dimension here, you see it says 0.236. If I try to actually type in 0.236, because it's got like 0.445 in there, I think it's going to come up all red. Yeah. You just can't solve it. So something is slightly off there. So what I'm going to do is I'm just going to hit Control Z, undo that, delete out that dimension. I am going to dimension it, but since it's coming in at 0.236, and I might not even use this part, as you'll see, I'm just going to leave it as whatever that default value is. I think the only other things I have to do is put on the width of the shaft itself. So it's a 1/4 20 UNC, so it should be about 1/4 of an inch, but we're dividing it by 2 because we're only drawing half of that. And then the overall height of the of where the threads are, well, not just the threads, but where the shaft of that is 1 inch. And I think that looks about right. If I revolve this about that axis, revolve axis, region, there you go. It looks pretty good. We still have to add a hexagon caught in the top half, so let's draw a sketch on there. If you actually wanted to do threads on here, I'm not going to do it. I will just point you towards Google. So we're going to insert a polygon. We're going to click right on there. Um, go like that. You can then go up or down for the number of sides. I need to get 6 on the sides. So 6 sides. And it says it's 530 seconds across the flats. So if I throw in just a regular dimension here, from there, come on, having trouble picking that line. It is 5 divided by 32. And you see you got just slightly larger. It's all black, it's all good. I'm going to hit Shift E for extrude. We're going to select that area. I need to reselect that area. We're going to remove. We're going to send it down, which is doing, and the depth it says is 0.111. Under there, that seems good. That looks pretty good with the exception of we're missing just a chamfer on the bottom edge of 0.03. There you go. To put threads on there, you're going to need to draw in a helix. You're going to need to draw in the profile and sweep along that profile to draw the threads. I had very limited, I mean, I did it. I was unable to make it only go up 3/4 of an, or yeah, 3/4 of an inch, because it says a 1/4 of an inch offset here. So I wasn't quite able to make it do that. I did make it. Let's rename this part here, over here on the left side. I know I renamed the part studio. I don't understand exactly what the difference is here. I think this is more like solid in Inventor. So I'm going to rename this something I actually don't want to use. I'm going to call it stream axle, because I made it while streaming. Now I'm just going to go to my, let's also, well, it doesn't really matter color because I'm not going to put that one in. Now I want to go to my, come on, stop, my assembly. And my assembly is empty, so I just navigated over to that one. And I'm going to start inserting. And when you've done this right, it's going to work really, really nice. You see you've got all the names of your parts. You can see them. Seeing them will make it pretty easy. I would change the colors because they're all going to come in. They're going to be that light blue color. Hard to kind of see. So I'm going to choose the train body. And it's inserting the train body. I believe it's inserted one already, right? No. Okay. Click, and now it's inserted. I'm going to hit check. I can continue to insert parts, but I'm going to hit check right now just for a second. I'm going to right click on this, and I'm going to select fix. That's kind of like ground. That is now not going to move. It is stuck in place. That's what I want in order so I can put everything in there. I think the wheels make sense to put in next. So we're going to go put in some wheels, and then we'll get right to the axle peg. And I'm not actually going to make the whole thing, because you will. It's quickly very much the same thing. So I just keep clicking wheel and keep putting in more wheels. So I'll put in 4 wheels. I'm actually not going to put all 4 wheels on here in the video. It doesn't matter. So let's close that now. And let me restore. You have to hit the checkbox. So there are all your types of mates up here. And for the train project, almost every single mate is going to be what they call a revolute mate, meaning that we want to see it spin around. Or it has to be able to freely move. This is kind of like the insert command in Inventor. So I'm going to use this revolute mate. I'm going to select which connectors I want to make a connection with. I'm going to select. I want to select that one. I think I got that one. And come on, grab this one. It's grabbing the wrong side of the that one. Okay, so I've only gotten the one on the wheel so far, and that one. And now it automatically connects it. I like to click the little play button. It shows you, hey, here's how it works. When you see that, you can hit the checkbox down here, and you can continue making more of the same Revolut connections. So let's zoom in on this, grab that current side. So I'm grabbing kind of like that circle opening, and same thing on the face that I want it to mate up with. So I'm kind of like mating. It's just like insert. It's mating and aligning the centers on each of those. So you could go through and you can see, I'm going to go on the left hand side here, on your assembly, how everything goes together. It is all inserts with the exception of the stack here, not inserts, revolutes with the exception of the stack here. I'll get that one done in a minute. I do want to show the axle peg and some other things here. See how this all came in as part 1? All 4 of my wheels came in as part 1, which is really, really annoying. Even though when I went insert, I selected wheel, right? Well, if I go back to my wheel, so I'm clicking the wheel tab down here, I named the part studio CY_wheel, but I did not name the part once I've got the part made wheel. So I'm like, it doesn't make any, I don't really know why it's doing that or why it defaults to this one and you have to rename both, but that's their convention and we're going to adapt to it. So name this one. I'm going to do CY_wheel. I believe it should update. It should update pretty quickly. There is like a little, and you see now they're all named CY wheel, which, and then 1, 2, 3, 4 for the number of instances that it's in there. Right now I could grab this wheel and I could turn it. And it's hard to kind of turn the wheel, but I can. Oh, my wheel is missing the pegs right now, so I can't even put this whole thing together. That's okay. You guys can figure it out after you've sort of used the Revolut one a few times. You'll get it. I want to show the problem with the axle peg here, though, or like how to get one that's pretty close to accurate. So if I go to Insert and other documents, you could probably pull from anything, other things that you've made before. If you happen to make them all in separate part studios, I think you can bring them in. I haven't had much success, but you can look it up and you can probably get it done. I'm going to go over here to standard content though, and we have a supply of standard type things that are used all the time. So ISO, we've got some bolts and screws, they've got nuts, O-rings, all this stuff that's just typical hardware that is going to be used. So ours, as a quarter 20 UNC bolt, it's going to be an ANSI call out. We're going to look for bolts and screws. We are looking for one that has a socket head, so that it has the 6-sided hex portion in there. We're looking for a socket head cap screw. Let's see what that difference of that one is. Yeah, it's not quite it because we're looking for that rounded edge. It says socket head cap screw there. Button head, socket head, cap screw. That looks very similar. We're going to make sure that we get a quarter 20, so quarter inch, 20 threads per inch, and then we can change the length of that. We know ours is 1 inch long, and it's allowing us to change the material Although I don't think I can grab ABS, which is technically what it's calling for, because no one makes screws out of ABS plastic. So anyways, I'm just going to leave it as stainless steel. You can change the finish on it. We'll leave it at that. So the only thing that we don't have is the thing I couldn't create on the previous one, and that is the threads. I could create it. They're not perfectly accurate what I was going to create. So I'm just going to select this and select insert. And now I can put in one. Click insert again. I'm just going to do 2 of them. 2 of these. I hit the X. Hit restore here. Hit the checkbox. Don't hit the X. So you can see I now have 2 of those. And I wonder, did it automatically put in a constraint when I put those in? It might have. No, it didn't do any mates. All right, so let's do a revolute on them. I haven't tried this. We're trying this just for ourselves right now. Grab the outside edge of this one. Let's navigate underneath here. Grab that face. And it looks like they've gone together. I'm going to click the play. The wheel's moving. That's fine with me. We're going to hit this checkbox just so that we can do that again. Let's try the other way around. Move down here. Select that face. Select that face. That one, good. Came in backwards. So what can I do? I can click this button, flip the axes, and then click the play, and we can see that it's going to revolve. Looks like the first thing that you selected revolved. Doesn't really matter. They both will spin. Check. And we've got that all put in there. All right, the last thing that I'm going to show you on this is the stack. So I'm going to go to insert one more time. I'm going to select the stack. Hit the checkbox. And I cannot use just the revolute mate. If I try to pick that bottom edge, I do not have anything that I can be able to select and get a proper revolution on because of that curve that's in there. So I'm going to hit X here. That's actually what I want to do. I'm going to select not a fastened. I'm going to select a cylindrical mate. And then I think I made it like an edge or something. I'm going to have to do this on the fly. So cylindrical mate, just anything with a cylinder. Anything with a cylinder. And I'm going to hit the check. I guess I could have solved it. Close that down. I should be able to drag. This one I moved it up. So you know in Inventor you can move that up and down. Same deal here. So now I need to just align an edge. And it makes sense to take this edge here and try to get to that edge down there. Let's take a look at some of these. This is parallel mate. Creates a mate because there are 2 parts in an assembly. These parts can translate freely, rotate to one another. Ball, it's not a ball. Pin slot, don't think so. I use cylinder. Plane, I think I can do a planar mate here because we have a plane on the bottom edge and that is a plane as well. So I think that's what I'm going to do. I'm going to do a planar mate. Planar mate, select that plane, select that plane, and click play. Yeah, okay, so it's driving along that plane even though it can't do that because it's got a cylinder mate as well. So we'll put the checkbox on there. Now I'm going to grab this this stack and try and move it, and it's not letting me go anywhere with it. so it is properly mated. Um, if you look at it from the side, you see that it lines up pretty perfectly. It's down in there just a little bit, but that is acceptable as far as I'm concerned. So those are the difficult ones. You can make that threaded part yourself, but as you saw when I inserted the standard content, that should be the same one coming up here. If I insert this, you'll notice that it does not have uh, threads on it anyways. So let's zoom way in on it. There's no actual threads on it. So it's the same